The idea of an unlimited supply of space or quantity has mystified and intrigued great minds for centuries, as scientists, philosophers, and mathematicians alike have explored the concept of infinity.
What do you know about our universe?
I know that it's really, really big.
We always learn that the universe is constantly expanding.
The universe is infinite, like it just keeps going and going.
You know, we're just one little planet in one solar system, in one galaxy, in one supercluster in the universe, and it's always growing, it's getting bigger and bigger and bigger.
The universe, in my mind, is as big as you imagine it to be.
We are still exploring our universe, trying to find out how far it stretches and if it ever ends. The French writer Simone de Beauvoir once said, "I am incapable of conceiving infinity, and yet I do not accept finity." The notion of infinity has mystified mathematicians for thousands of years. Infinity refers to the concept of unlimited extent of time, space, or quantity. This is the symbol for infinity because it has no beginning and no end. One question that remains is whether actual infinity exists in our physical universe. Is there an infinite number of stars? Does the universe have infinite volume? Does space go on forever? The concept of infinity is separate from having boundaries. For example, the surface of the Earth is finite, yet it has no boundaries. One theory argues that a similar principle may apply to the universe. If you flew a space shuttle straight ahead long enough, you would eventually reach your starting point. In mathematics, the concept of a limit is used to describe the behavior of a function as the variable gets close to either some number or increases or decreases without bound. Here is a geometric example of limits. Look at the area of a regular polygon inscribed in a circle. What happens when we increase the number of sides of the polygon? The polygon is getting closer to becoming the same size as the circle. If we refer to the regular polygon as an n-gon, where n is the number of sides, we can make some equivalent mathematical statements. As n gets larger, the resulting n-gons get closer to being circles. As n approaches infinity, the resulting n-gons approach a circular shape. Consider another sequence, where the nth term is given by n over n plus 1. We let n equal 1 to get the first term of the sequence. We let n equal 2 to get the second term of the sequence, and so on. We see that the terms of this sequence are getting closer to 1. However, no term will ever equal 1. So we say that these terms are approaching 1, which is the limit of the sequence. As n grows larger, n over n plus 1 gets closer to 1. Now look at the sequence where the nth term is given by 1 over n. The sequence looks like this. As n gets bigger, these terms approach 0. Look at an example in graphical terms. We can draw the graph f of x equals 1 over x. The x-axis is a horizontal asymptote. We see that as x gets larger, the graph gets closer to the x-axis. So as x approaches infinity, f of x is approaching 0. This is called a limit at infinity. Limits may help us understand the concept of infinity, but the idea of the universe's infinite mass still mystifies many scientists.